Take a moment, read through this problem, then go ahead and pause the video and work it out for yourself first before we go and work it out together. Now, to help us see what's going on in this situation, we know we have a rectangular area that we need to fence in, but it's along a river, and so they need no fence along this particular river. So when I draw out the picture, I'm seeing a rectangle, but there's this side along here that's along the water where we don't actually need any fence, so that will not be included in it. All right, now the number that I'm being given up here at the start is this 3,600 yards of fencing. So I know I'm going to start with an equation that involves that. So I got 3,600 equals. Now that's yards of fencing. So that's like around the outside here. So I need to say how much total fence is that. Now I'm going to stick with variables like length and width here. So I'm going to go ahead and call this my width, making these two both length. Which means that if I want to find the total length of fencing, that would be 2L plus W. All right, now I know I'm going to need another equation in order to be able to do this. The other equation always comes from whatever it is that we're trying to maximize or minimize. In this particular problem, we're being asked what are the dimensions of the largest grazing area that he could encompass. Awfully convenient for us to use the word area there. So it tells us that it's going to be an area equation that we're going to be trying to maximize. So I'm going to do area equals, and the area of this rectangle would just be length times width. Now that I've gotten this far, I want to make this equation have just two variables in it, the A and either L or W. So I'm going to take the first equation and I'm going to solve that either for L or W. In this case, it seems easiest to solve for W. So that's what I'm going to do. I'm going to subtract 2L from both sides, which gives me the equation 3,600 minus 2L equals W. And that's now the equation that I'm going to substitute in for W in this equation. So my new area equation is now L times 3,600 minus 2L. Now I think it's probably going to be a little bit easier if I go ahead and distribute there, so I'm going to distribute that L in. So we're going to make that into 3,600L minus 2L squared. All right, now remember, I'm trying to find the largest grazing area. I want to maximize the area. Maximizing something means finding its derivative and setting it equal to 0. So let's do that. We find our derivative first, so that's going to be A prime equals 3,600 minus 4L. Now, I want to set that equal to 0, and then solve for L. So we worked it through and found out that L is 900 yards. Now that I know that, I can now figure out what W is. Now remember up here, I had an equation for W. I already solved for W. So I'm going to make use of that now. So it's going to be 3,600 minus 2 times L. But now I actually know what L is. L is going to be 900. And that's going to equal W. And so we end up finding that W is 1,800 yards. So notice that this did not end up being a square, as some of our instincts sometimes would suggest, because this bottom side here is along the river, and so we don't need fence along it. It changes up some of those proportions that we might be used to in order to maximize area. So yes, we actually got to go through some of these steps and figure this out.